welcome back to our video. It's Zizi and Tori. Okay, so last week we talked about like ranking of lip glosses and stuff, but this time we're gonna talk about
resonance and formal charge.
a lot of you guys were asking for us to talk about that on our Twitter. I don't know why, but I guess we'll do that today.
So for this video today, we invited our friends Roxy and Declan to help us explain it.
Okay, hey guys, so we just got to the lecture room where we're gonna show you guys how to do resonance structures, but we are gonna need help, so we brought Roxy, which is one of our chemistry friends, and she is gonna talk to you guys a little bit and introduce herself.
Hi, I'm Roxy, and I'm here to talk about chemistry, resonance structures, and formal charge with you guys. I hope you guys enjoy it.
Yeah, it'll be super fun.
Wild boys, bad girls. It's about time we bring on the heat. Now I'm sure all of y'all daredevil freaks can relate when I say something ecstatic is on its way. When the BPM is rising, your body starts to sweat. The adrenaline just picks you up and the inner you goes mad. Can y'all feel it?
Okay, so for formal charge, you need to know the number of valence electrons that are on that atom, the non-bonded electrons, the number of bonds, and all of this, with all this information, you're able to figure out formal charge. So basically, for example, if you take oxygen and you look at the bonds I drew, there are 1, 2, 3, 4, 5, 6, 7 total. So oxygen has 6, and you can look at that by looking at the periodic table. So it's 6 minus 7, and 1. And that is the formal charge of oxygen. And you could just do this for all of their atoms.
So basically, what we have here is nitrate. So important thing about valence shells and formal charges is the octet rule, because having 8 electrons in a valence shell is a very stable thing. So if you actually count with each bond counting as 2 electrons, since 2 electrons in a bond, you'll notice that each of these has 8 electrons, which is perfect, which means all of these are stable. But now, you'll notice nitrate, NO3, has a charge of -1. So now why is that? That's where formal charges come in, because in the valence electrons they start with, for example, nitrogen has 5. And so if you notice, based off what we talked about formal charges, this has 1, 2, 3, 4. So 4 out of 5, it has a +1 charge. Now, you'll notice on this one, 1, 2, 3, 4, 5, 6. This carbon's happy, this has a formal charge of 0. But each of these has a formal charge of, well, 7 for formal charge counting numbers. So these each have a -1 charge. So 2 minuses, 1 plus, a minus charge.
So here's one structure of a nitrate molecule, and as Declan explained, there's 2 negative charges and a positive to cancel out to make one molecule that makes a negative charge. But there's different ways that you can write this structure. And so another way would be is if you take these 2 lone pairs off this oxygen and you add it to here, and so it's a double bond, and then you make this bond come back out and have 2 lone pairs on this oxygen instead.
So as you can see, because there's 2 one bond and 1 double bond, they're still the same molecule and they'll still have both the same charges. Like nitrogen is still positive, and there's going to be 2 sets of negative oxygens, 1 and 2.
Thanks for watching this video.
Make sure to like and subscribe.
And leave any questions or comments down below. This video was sponsored by Crayola Chalk, which is what we use to make this video possible. Make sure to buy our merch. It just came out online. And we'll see you in the next video. Bye.
Bye.